Good evening and welcome, fans, to another exciting edition of My Boring Math Videos. Today we're going to be talking about functions, just a little bit about functions, not too much, but we're going to expand on it as we go further. First things first, say I have this machine here, and I want to put things in this machine, and I want to get things out. So I want to explain how this usually goes. So say, for example, I put the word out in my machine. Get the word in out, right? Say, for example, I put the word, say, for example, I put the word true in my machine. What word do you think I'm going to get out? You got it. False. So as you can see how this function is working. Whatever I put in is going to spit out the opposite. That's the whole idea behind what a function does. Whatever you put into it, it changes it and spits something different out. So what we can do is we can actually do it with numbers. Say I put a 2 inside of my function and I get a 3 out, meaning I would actually have this. Now, the way you say that is f of 2 equals 3. So there's a word right here that of, and you say f of 2 equals 3. So when I put 2 in my function, I got 3 out of it. When I put 3 inside of my function, if I'm following the same exact pattern, I am going to get 4 out. So what that means is that f of 3 is going to give me 4. So basically what this function is doing, whatever I put inside of it, whatever number I put inside of this function, it adds 1 and spits it back out. And you can actually see from here, the way we got from 2 is, well, from 2 to 3 is we did 2 plus 1. And the way we actually got 4 is we did 3 plus 1. So if in fact I wanted to know what I would put inside of my function to get out 5, I would put 4 in, wouldn't I? Because if I put 4 inside of my function, I would get 5 because I would add 1 to it. Let's just show it this way. There we go. So basically the rule for this function, whatever number I put in, remember when I said that x represents any number, whatever number x that I put inside of this function, it is going to add 1 to it and spit it right back out. So that's the whole idea. So if you ask what a function is, pretty much it is a system that you put something in and it spits something out. That's all it is. Your book will probably tell you a different definition, but that's in its simplest terms, that's exactly what it is. All right, so let's talk about other forms, well, components of a function. We talk about the domain. The domain of a function is just everything you put inside of it. So whatever you put inside of your function, that's what the domain is. If we go backwards, if we look here, all the things that we put inside of our function are right here. So basically what that means is that our domain, in this case right here, is 2, 3, 4. Those are the things we put inside of our function. This is just the rule. That's not necessarily part of our domain. That's any number x that I put inside of it. But in this case, I just use 2, 3, and 4. So that's my domain. All right, so moving forward, the domain is everything we put inside the function. The range is everything we get out of it after the function does what it does. So we have the domain, we have the range. In this case right here, if we're looking at our range, here we got 2 plus 1 equals 3, 3 plus 1 equals 4, 4 plus 1 equals 5. So in this case right here, our range was 3, 4, and 5. All right, so back to it. The range is everything that comes out of the function. All right, now when we actually are talking about the range, it usually depends on whatever the domain is. Whatever the domain is basically what we're going to get. We'll actually see an example as we go. In order to find out what your range is, just whatever element from the domain you're going to put in there, that's what you're going to replace x with. All right, so notice here, if we work backwards from this function right here, Wherever you see an x, you're just going to put whatever number from your domain. So if we started at f of x equals x plus 1, we put 4 in, we change this to a 4. We put 3 in, we change this to a 3. We take 2, we change that to a 2. So that's what I mean when I say replace x with a member from the domain. Now, let's actually do an example so you guys can see it. If it says list the range of g of x, we can also use a g instead of an f. List the range of g of x if 4 plus 3x minus x squared equals 4 plus 3x minus x squared if the domain is this. So if that's the domain, what we want to do is we want to take each element in the domain, put it in our function, and see what we get out. If you look, for example, we're going to take -1. That means we want to find out what g of -1 is, right? So if in fact we want to find out what g of -1 is, remember what this says. This right here says replace with a member of the domain. So replace x with a member of the domain. So everywhere you see an x, like say for example here and here, you're going to replace with -1, in this case of g of -1. So let's see what happens when we actually do that with each element in the domain. We get this. Now, basically what this shows you, it shows you the rule of the function, whatever I put inside of it. When I put a -1 in, that means I replace this x with a -1, and I replace this x with a -1. And if I put 0 in my function, I do the same thing. I just replace it with 0 instead of -1. If there's a 1 right here, I replace these with 1. If there's a 2, I replace it with 2. So as you can see, I use the domain just -1, 0, 1, 2. What the range is going to be is whatever the function spits out after it's done. Now here is what the function does to whatever I put inside of it. It pretty much plugs it in there. So that's what the function actually does. So if in fact that's what the function does, our outputs are going to be these numbers right here. So looking at those are going to actually be elements of our domain. So we can actually say from here it says list the range. Our range is going to be 0, 4, 6. The reason why it's just 1, 6 is because it's already in our domain. It doesn't matter if we get it twice, but that's just in our range. That's one of the numbers that we get, even though we got it twice. So that's the whole idea behind it. If in fact I go and give you an example on your own to do, let's see if we can try it. Now we're going to try it the same exact way that we did the last one. It says list the range of f of t equals 4t minus 3 if the domain D is equal to 1, 2, 3. So go ahead and try it and see if in fact, well, before you actually try it, let's do one of these so we have an idea. Let's put 0 in our domain and see what happens. So for the most part, I want to find out what is f of 0. F of 0 is going to be 4 times 0 minus 3. And if I do 4 times 0 minus 3, that equals 0 minus 3, which is -3. I'll do one more just so we have a great idea of how to find these. We have f of 1, which is going to be 4 times, not that right there, 4 times 1 minus 3, which is 4 minus 3, which is just 1. All right, so try the next two on your own. Pause the video, try those, and see what you get, and then match it up with me after you come back from pause. All right, so go ahead and pause the video. There you should have gotten this. When you plug 2 inside of the function, you should have ended up with 4 times 2 minus 3, 8 minus 3, and you should have got 5. When you plug 3 into the function, you should have went through the motions and got 9. So that means our range in this case, since our domain is 0, 1, 2, 3, our range in this case is -3, 1, 5, 9. Now, what if our domain wasn't so limited to just 4 numbers? What if it was all real numbers? We can actually put anything in our function just to see what's going to happen. Now, this function, f of x equals x squared minus 2x. So whatever I put inside of my function, it's going to square it, and it's also going to multiply by 2 and then take the difference between it. So let's go through it and find out what actually happens. What if I put 4 inside of my function? So I want to find out what f of 4 is, meaning that wherever I see an x, I'm going to put a 4. So notice I'm using this equation up here. Wherever I put an x, I put a 4. So that means 4 squared minus 2 times 4. And when I go through it, I should have gotten 8. All right, let's put something else in there just to see. If I put negative 3 inside of my function, that means that I'm doing negative 3 squared minus 2 times negative 3. And when I go through that, I should have gotten 15. So why don't you guys try to find out what f of 2 is? If in fact that's f of 4, that's f of negative 3, find out what f of 2 is. And once again, if you'd like to, you can pause the video and you can figure out what it is, and then you can come back. So go ahead, and if in fact you're going to pause the video. All right, so once you're plugging in 2, you're plugging in 2 to actually get here 2 squared minus 2 times 2, which is 4 minus 4. You should have got 0. So in this case right here, what we got so far in our range is 8, 15, and 0. So why don't you guys try the same exact thing with this function right here? I want you to pause the video this time, and I want you to find all 3 of those and see what you get and match it up with my answer. So pause the video again. So you should have gotten something that looks like this. We plugged negative 1 inside of our function, we ended up with 2. Plugged 0 in, we ended up with 1. Plugged 2 in, we ended up with 5. So this is what we're going to be doing for the next time we have class. And it's actually fairly easy. So that's all I have to say. Now I can go home. Bye.